Alright, despite how this video is starting, I'm actually making this introduction after. I'm making this after I recorded the whole video, so this is later on in time, but I feel like I'm emerging from, I'm not a religious guy, but I feel like I'm emerging from Noah's Ark. We have had so much rain. I mean, just nothing but rain. That whole field, there was a river running through that field down there. I mean, literally water rolling. You could float a small boat in it. And it's the first sunny day in a week. And you'll see how cloudy it is on the next video, on the next segment of this video. But, I mean, I haven't been outside for a week. And the grass is, getting long, and my piece of crap John Deere, I got to get that out and cut. I know a long time ago I made a video, I don't know if I've been outside, but a long time ago I made a video where I started out showing the horse barn over there, and they were just building it. It was just a structure, so the barn is in. This is my neighbors across the street, and the barn is in, and horses are over there. They have two, they had three, they have two right now. There's the, you can finally see things, nothing but clouds. There's the Blue Ridge Mountains over there. That is the Blue Ridge Parkway on top of that mountain. Doing a little yard work here. These mushrooms, they pop up literally overnight. Feels weird being outside. Feels strange seeing the sun, blue sky. So much rain that I'm out in the country, so I have well and I have a septic tank. And so much rain. This house is maybe 3.5, 4 years old, I don't know, but so much rain that, this is my septic tank right there, that the walls of the septic tank's a big concrete vault, okay, it's fine, but where they backfilled it during the initial construction, I guess they just threw dirt in there and didn't pack it down or tamp it, and there was a void in there, a little cave, and it started collapsing. So all along the side of the tank, it just started collapsing down. So I've since pushed it all down and refilled it with some dirt here. As you can see, I've got a few acres here, and it's a mixture of grass and weeds and hay, and I don't care as long as it's green. If it's green and it grows, I'm down with it. But finally a nice day. And what I'll say about the video that I'm about to make is it's that I've already made actually. It's surprising. And for those of you who like technical aspects and troubleshooting and that sort of thing of audio electronics, you might find it interesting. And there's a bit of a surprise in there. Well, kind of a surprise. But my AS-1100 stopped working, and I had to troubleshoot it. So that's what this video is about. I was so disappointed, not disappointed, I was a little bit upset, because it happened during, and I'm sure I'm going to cover this again, I'm sure I already covered it, happened during a series of thunderstorms, and happened during a bunch of power outages, and powers out and then on and off and on and off and on, and then the AS-1100 just stopped working. It wouldn't power on. And it's still under warranty. It's got 2 years, but I can't stand not knowing, so I figured, okay, I'm just go ahead and tear it apart and try to figure out what's wrong. And this video is about that journey, and I hope you find it interesting. And even if you're not versed in, or not versed, but even if you're not that interested in the technical aspects, there is a lesson to be learned, not only about the AS-1100, but about any piece of high dollar equipment, let's say, but also specifically about the 1100. So if you have the AS-1100 or any of the AS series Yamaha amps, there's kind of a moral to the story, I think, and hope you find it useful. Enjoy. Hey, this is Stereo Police back with another video. This one is not one I really wanted to make because it has to do with a little old problem I'm having with my favorite amp, the AS-1100 Yamaha. And well, let me start out with the problem, then I'll give you a little background. Well, the problem is it doesn't come on. Nothing. Not even a click of a relay. No lights. No nothing. Okay, sorry, I had to hit pause there for a second. And Jasper decided to join me here. So, again, nothing. And I had it plugged in to a really outstanding power conditioner, the Furman. What model number is this? I don't even know, but it's really nice power conditioner and protection, and it was plugged into that. And the other night, when the amp stopped working, we had a series of really bad storms. We had power outages. I do have a whole house generator, so we'd go for those periods of 10 seconds, and then the generator would kick on, and then the power would come back on, generator turns off, and it cycled through that a few times. And then we lost power that night for about 5 hours until the wee hours of the morning, and then it came back on. Anyway, so the next night I came down, and I listened to my stereo every night, and it wouldn't work. I mean, absolutely nothing. So naturally I thought, well, okay, we had a power surge and the protection kicked in and something is damaged inside of here, but yet everything else plugged into it is working. So I took an outlet tester and put it in back there, and the power is normal coming out of the Furman. And just for kicks, I plugged the AS-1100 into this, and I know that this is charging my computer there, my tablet. I know this is working, and still nothing. Went to the back, checked the power cord where it plugs in, wiggled it around, made sure it was tight, no problem. So something is wrong with the AS-1100. And that's what this video is going to be about. It's a little dusty. Wow. I have no idea what's wrong with it. And so I figured I'd make a video about the troubleshooting process of troubleshooting audio gear. Because we're starting from scratch here. But one clue that I have, not that it's much of a clue, is that nothing comes on. Sometimes when something goes wrong internally, you'll flick this power switch and the lights will come on, but you'll get no sound, or the lights will come on, you'll get one channel, not the other channel. Sometimes you'll flick the power switch, the amp will come on, and then it'll immediately, both channels will work, and then they'll go out again. Click, click, the protection circuitry kicks in. There's all kinds of symptoms, but this symptom right here, the fact that nothing comes on, no lights, no clicks of the internal relays, nothing, this is a clue that whatever's wrong is way upstream. When I say upstream, I mean near and around the actual power transformers. Could be the internal fuse. That would be the first thing I would check, and then I'm going to check. But it could be any number of things. But one of the things during the troubleshooting process, you have to kind of know the fundamentals of how the amp works, the design theory, the theory of operation, I should say, in order to properly trace the faulty portion of the circuit. So I figured I would go ahead and just do some real basics of the theory or the principle of operation of how this thing turns on, because that's where we're going to start. It's not turning on. And then we'll open it up and try to figure out what's wrong, and the simplest problem would be internal fuse. Now, why an internal fuse would blow, I don't know. This thing is plugged into the Furman. The Furman protects against spikes and noise and power fluctuations and all kinds of things. And I don't know. I don't have a clue why the internal fuse would blow, but it did blow during thunderstorms and during power outages. So, I don't know. We'll cover that in a minute, but two more things. For those of you who have watched my previous videos about my sound room down here and about the clips and all that, a couple things, a couple updates. Number one is I said a few minutes ago that I listen to the amp every night, and sometimes I'll sit in here and just listen to music or do some critical listening, or I've got a back behind those ugly drapes, I've got a workout area. I'll be working out back there while listening. But one thing I did do is I installed, because when I sit outside here, I'm about to go outside, when I sit out back here, I used to have to open that window right there to listen to the clips out here and crank them way up to hear them out here, but that would let in a lot of dust and pollen and bugs and things like that. So I went ahead and finally installed some outdoor speakers, and there they are. They're awesome. They're PSBs. My apologies, I forget the model number, but they're PSBs, and they sound great. They're outdoor speakers. They work fantastic. Also put in a fan too. Put in that nice dual ceiling fan. It's an outdoor fan. I installed that. So I've got a pretty nice little area to sit out back here. It has been raining in where I live for more than a week. Thunderstorms every day, rain. It's miserable right now. Look at way over there, dark ass clouds. So it's kind of cool to have those PSBs out here, and they are hooked up to the Yamaha. Maybe that's a clue. No, it's not, because if something would have shorted or gone bad with the PSBs, the amp would kick on, but the protection circuitry relays would kick on, and you'd still have power to the amp, just no sound. So I don't think that's the issue. I don't think it has anything to do with shorting out of the amplifier or anything like that. I really think it's an internal fuse, but it could be something else. And the other thing I just quickly wanted to address is I've gotten comments, and the two comments I've gotten about the ugliness of my sound room were, well, they were really nasty. I mean, I would have addressed it if someone would have politely suggested that my sound room is ugly. But anyway, I agree. I don't really have a room in this house that's conducive to my stereo, other than this one, and I kind of like it in the basement because I work from home and I'm upstairs all day long, and after work is finished I want to come down here. It's different, change of scenery, sit out back. You know, when you work from home, you just, after the end of the day, you've got to get a different environment. So this is it. And one day I do plan to fix this sound room up. I plan to do some drywall and many other things down here, make it a nice room. However, I cannot do that right now, and I do not want to do it because for the last 2 years I've lived here, I've had someone living in the basement. Someone lives down here, my nephew, and I'm happy for him. But before my nephew, when I first moved into this house a few years ago, my brother-in-law was in between jobs, and he lived here. And then he finally got on his feet, and then my nephew needed to get on his feet, so I invited him over to live down here. He's doing great, but he lives in this area, so I have to share this area with him, and I'm not ready to put money into finishing this basement until he's gone, which will be probably another half a year or so, a little bit more than that. So I'm just leaving it unfinished for now, but I do want to say I fully agree with those who say, rightly so, that the acoustic environment of the listening room has a tremendous impact on how your speakers are going to sound. And I fully agree with that. I just cannot finish this room yet and do it up the way I want to for another year or so. So I'm stuck with what I would agree. I would agree to being an ugly, less than desirable environment for a sound room, but it's what I have. So I just wanted to address that. But I agree with those who say I should fix it up, and I'm going to one day. Okay, so what I'm going to do is I need to get this beast off the rack here and onto the bench. That's step 2. And then we'll talk about the theory of operation of how the amp starts up. It's kind of interesting. I had to study the schematics for a while for that. And then we'll open it up and see if we can figure out the problem. And I thought it would be, well, number one, interesting just to show you, for those who are interested, how the troubleshooting process works. And second of all, for those of you who own one of these amps, well, perhaps this very same problem will happen to you. I don't know. If it does, you'll have this video. All right, let me go pull that beast in here. Okay, so what I have here is a portion of a block diagram of the power section of the amplifier. And because the thing is not turning on, we need to troubleshoot upstream, starting with where the power comes in. And as I mentioned before, you cannot troubleshoot unless you understand to some degree the theory of operation. You know, fundamentally how this thing works. And so I've already studied the schematics, but it's probably easier to look at this block diagram, and I'm going to add a few things to it. But it's interesting how this thing powers on. You know, back in the day, you would have 100 and your 120 volts, or whatever country you live in, 100 volts or whatever it is, from the wall, and there's always a power transformer, which steps up or down the voltage, and it provides isolation. And then you would have a power switch and a fuse, and it would look something like that. And your power switch is what simply turns the amp on and off. As soon as you close that switch, power goes to the primary of the transformer, to the secondary, and then to the power supply, and to all the components. Turns the amp on. And that's the simplest arrangement. But as things became more sophisticated, and there's microprocessors in the circuitry and that sort of thing, for many other reasons, nowadays this switch has been replaced with a relay, and that relay is controlled through other means. So let me just scratch that out. And here is the relay. Now, there are two transformers, two separate power transformers in this amp. One is this big one right here. This goes way up. There's more stuff coming off of. There's many windings on the secondary for different voltages. But this is the main transformer that controls almost everything. And it's turned on by a relay, and it has a fuse. Now that's the fuse we need to check out. I have no idea where that fuse is inside, but we'll find it. It's got to be highly visible when you take the cover off. And that's the first thing I suspect. Now, just on the off chance that it's not the fuse, and I have some doubts, I have some reservations whether that fuse is blown. Some part of me thinks it's not, and it's something else. And I'll get to that in a minute. But quickly, the theory of operation of how this thing turns on, and this will get us started with the troubleshooting process, and then we'll go from there. Okay, so this relay is normally opened. And by the way, relay, if you don't know, hopefully you can, if you can see this, a relay is just a device that uses a low voltage to control a high voltage. And I don't know, it's got a coil, and you have your low voltage across the coil. Could be 5 volts, could be 3, could be 12, who knows. And then on the other side you have the switching part of the relay. I'm going to draw it like this. And you have, yeah, you can see that. There are many configurations, but a simple relay, you have a normally closed and a normally open. In other words, when this relay is resting and there's no voltage to it, there's no voltage to the coil of the relay, then this, these are contacts. This is a short circuit, that's an open circuit. And as soon as you apply a voltage to the coil of the relay, then this goes in the other direction. Click. That's where you hear that click. This is literally, you know, on a spring. And then the normally open side, when you apply the voltage, becomes closed or a short circuit, and the normally closed side becomes open or an open circuit. When you remove the voltage, it goes back to its resting state. Now, the reason why I bring that up is this relay here is normally open. In its resting state with no voltage applied to the coils. And by the way, the coils are right here. The coils that control that relay. Okay, so it's normally open. So how do we get from the power switch to get that relay to turn on? Okay, because when that relay is not on, almost everything coming from this transformer, everything coming from this transformer is off. It gets no power. Well, the way we control that relay is with they call it a sub-transformer right here. And you'll notice the sub-transformer is not switched. As soon as you plug the power cord in, this sub-transformer, the primary, there's the secondary, gets power. Okay, so it's got, as soon as you plug it in, it's got power. Okay, this is just a rectifier right here so that we get DC out. Okay, so plugged in. Doesn't matter whether the power switch is on or off, this gets power. Now here is the power switch. It's in the secondary circuit. This is what's on the front panel that you turn on the power with. Okay, so when the power switch is off, the primaries are getting power, but the secondary circuit is open and no power comes out. Okay, so as you can see with the power switch off, yes, the primary is getting power, but no power is being supplied anywhere else. So what happens when you turn that power switch on? Okay, as soon as you turn it on, you complete the circuit, okay, to the rectifier, and the rectifier, it just produces DC from AC. That's all it does. AC comes out of here, and this rectifier produces DC filtered. There is a well, that's a capacitor right there. I guess that's the filter. This is not an accurate depiction of the exact circuitry. This is more of a block diagram level. Okay, so we turn the switch on, we get DC here, and as you can see, we go into an integrated circuit, which is probably a I haven't looked that up. Probably it's almost certainly a what do you call the thing? A regulator. It just regulates the voltage precisely. So it goes into a regulator, regulates the voltage, nice precise 5.6 comes out, and where does it go? It goes to the microprocessor, it goes to a standby LED, and then it goes to some circuitry, some peripheral circuitry around the microprocessor. So as soon as we turn that switch on, we power up the microprocessor. That's the brains of the whole amp. But still, though, we haven't addressed how that relay turns on. Well, I can tell you from studying the schematics, two things. Number one, that relay is controlled by this transistor right here, Q2. And this transistor, which is nothing more than an electronic switch on-off, that's all it is. This transistor is controlled by something called relay power. And when you trace the schematic, the relay power comes directly from the microprocessor. Okay, so let's go once again through the power up cycle. Okay, we plug the amp in, we got our 120 volts on the primary, we turn the power switch on, DC is supplied to power up the microprocessor. The microprocessor powers up, the microprocessor sends a relay power to this transistor turns on, becomes a closed switch, provides current to the coil, this guy right here, of the relay, which causes the relay to go from its open state to a closed state. Once the relay is in a closed state, it will power up the main transformer and everything else will come on. How's that? That's how the power on sequence works on this amp. And this will become perhaps critical to know if we need to troubleshoot beyond a simple blown fuse. So we can see that if, now I'm speculating now because I haven't opened the amp up, it's sitting right next to me, if the fuse is blown, when you turn this switch on, it will, assuming all the circuitry is working here, it will provide power to the microprocessor. And the microprocessor will provide power to the power transformer. I'm sorry, to the relay control. And the relay control should close this relay. Should. But I don't hear that relay clicking. Now, that relay should click regardless of whether that fuse is blown. That relay doesn't care if the fuse is blown. It doesn't care what's hooked up to it. It's just a switch. It's going to open and close. And this circuitry right here, if it's working right, I should at least hear the click of a relay. And even if that fuse is blown, nothing else will come on, but I'll hear the relay click. And I'm not hearing that, which is concerning to me that something over here is not working. Now, my big concern is that somehow in some way there was, through the, and I don't know how this would happen, through the, somewhere during the thunderstorms there was some kind of a surge that made its way through my Furman protection circuitry, my Furman protection box, and fried the microprocessor, because microprocessors are extraordinarily sensitive to spikes and surges and electrostatic discharge, ESD, and they're sensitive to over voltages and that sort of thing. There's a regulator here that controls that, but there are just so many things in the way to prevent that from happening, including my surge protector, my Furman. So I'm at a loss right now as to what would happen. Again, I expect to hear the relay regardless if that fuse is blown. And I certainly don't know how the microprocessor would detect a blown fuse and not turn the relay on. There's nothing in the circuitry that would do that. But we shall see. So now that we know the theory of turn-on operation, it's time to start troubleshooting. And the very first step of troubleshooting is, well, it may sound stupid, but check the power cord. Plug that power cord in and make sure that voltage is coming out of it. And that's what we're going to do first. It may sound dumb, but you know, power cords can have internal failures. It's pretty rare, you know, it's extraordinarily rare, because there's not much to go wrong with them. They're, you know, presumably they're all soldered internally at the ends and at the receptacle end and at the plug-in end, and what possibly could go wrong with it just sitting there operating? I have no idea, but the, you know, troubleshooting begins here, and it's going to start flowing in a sequence. You know, we keep tracking the voltage until we don't find a voltage anymore, or until we find something misbehaving. We just keep going through. But again, I'll be kind of embarrassed if it turns out to be a blown fuse, because I can't explain why I don't hear the click of the relay. Okay, I know I'm repetitive. I'm just sort of thinking out loud here as I go. It's sort of the troubleshooting process. So let's go ahead and test the power cord and then open it up, and first thing we're going to do is look for that fuse. Alright. Okay, so I have the power cord plugged in, and I have my meter probes plugged right into the end of it, and we have 123.2 volts, roughly what it should be. So we know the power cord works, right? So now, time to open it up. Alright, well, that was quite a process. That was one of the more complicated teardowns that I've ever been a part of. Lots of screws, lots of things to move. Had this one bracket zip tied to the center to keep it out of the way. The side, I'm not touching it now because it's live, but wow, just to get to the board, the circuit board down there where the fuse is, was quite a process. Honestly, I don't recommend it, but now that I've done it, the next step is to, as I've done, plug it in, and I'm checking the back side of the receptacle just to make sure there's nothing wrong with the receptacle, which is highly doubtful, and we are receiving our 120 volts. So far so good. The next step is to check the fuse, which I have located right there. And for that, I'm going to turn the power off and to remove the fuse. Alright, fuse removed. Have it on continuity check. See if I can do this with one hand. Fuse is good. Alright, well, that's what I suspected. Suspected it had something to do with the microprocessor or upstream. Wow, this stuff is really tight in here. It's going to be a real challenge to even get access to some of these test points without really ripping this thing down. Let me think about this. Okay, so the next step is, well, I want to know if this little sub-transformer this little guy right here that we talked about earlier, is he putting out power on the secondary, or is this transformer bad? So I just disconnected the connector to the power switch that comes from the secondary of the sub-transformer, and probing it with an AC voltmeter. Okay, that's the connector that goes to the power switch, and I'm getting 9.4 volts AC. So that transformer is working. So far we know the fuse is good, and we know we're getting power to the primary and out of the secondary of that transformer. The next thing I want to know is whether or not the relay, the transistor right here that turns the relay on, is it getting relay power to the base of that transistor? Because if it's not, then that means the microprocessor is not sending it. So that would be the next step. Now that's a little more challenging because all this stuff is tucked up in here and I really don't know how to get to it without removing this upper circuit board right here to have access to that one. So I've got to put some thought into it. I'm not quite sure how deep I want to get into this. Maybe I better check the warranty, huh? I have no idea. I don't remember what the warranty is on this and exactly how old it is, but beyond a certain point, if it's going to require replacement of circuit boards, then if someone else is going to do it for free, I'd rather that happen. However, if it's out of warranty, then I'll just continue the process and take it down to the board level and see if I can get a new board. I don't know. I'm just thinking out loud, but I'm going to continue on with the troubleshooting process and see how far it gets me. Okay, so it's been about a full day since I cut the last video, and I've since reassembled the amp because I got to a point where I figured, okay, I'm going to have to start removing circuit boards and, you know, removing too much stuff, and I know the thing is still under warranty. I believe it's 2 years. And I figured, okay, well, if it's the main microprocessor circuit board, then that's going to have to be replaced. I don't want to do that. But then it occurred to me, I probably unnecessarily took this amp apart and checked the fuse. Although I like doing things like that, it's enjoyable and it was interesting, and it's really no problem at all. And I learned a couple things along the way. But it occurred to me that I should have read the service manual a little more closely, and I've since printed it out, portions of it right here. There is a self-diagnostic function, and for some reason the portion of the service manual, this shows up on page 29, but the previous pages depict some sort of special service device being plugged into the microprocessor circuit board, and I somewhat assumed that I needed a special device to go through this diagnostic, but it turns out I don't. The diagnostic can be done completely from the front panel of the amplifier. And the previous pages here that showed that special device, that was merely for updating the firmware. It has nothing, that had nothing to do with the diagnostic. So I sort of conflated the two and assumed I needed the special device. So upon reading the service manual a little more closely, I realized that I could do the full diagnostic, and I did it. It's kind of complicated. I had to read pages 29 through 41 about 4 or 5 times just to figure out how to go through the whole procedure and what everything meant. But long story short, I did it, and the receiver works, or the integrated amp works. And it turns out that when I went through the diagnostic, I pulled an error code because I had 8 flashing lights on the front panel, and when you enter the diagnostic mode, you'll get these flashing lights, and it'll tell you which portion of the protection circuitry has kicked in. And I got 8 flashing lights, which means the PS amp protection kicked in and was preventing the amp from working. Where's the description of PS amp? That's just amp protection. Yeah, okay, so there it is, amp PS amplifier protection. That's PS stands for power source, and the cause of this protection circuitry kicking in would be abnormal voltage of the amplifier power source. Now the power source is, you know, plugging it into the wall. So the microprocessor discovered there was an abnormal voltage there and kicked in the protection circuitry, and it stays kicked in until you reset it. So in effect, what I ended up doing was resetting it, and click, you hear the relay? Click, that's a good sign. The lights, the LED lights have lit up, and I have a signal. I have a 1 kilohertz tone feeding the CD input, and I've hooked up my test speakers here that I don't care about if they blow. And the first thing I did was test for DC voltage across the output transistors, or across the outputs, and there's no DC voltage. There's just a little tiny 22 millivolts, that's nothing, on one side, and it's a little less on the other side. So there's no DC, that's the thing you want to check for. And then the test tone, there it is. Turning up the volume. And let's go to the left channel, the right channel, left, right. Everything works fine. Change the input selector back to CD. Everything's working fine. Meters off. Meters on peak. Speakers off. Speaker A. I have nothing hooked up to B. Off. So basically, and I was thinking, okay, well, I had this thing hooked up to that pretty expensive Furman power conditioner, and everything else hooked up to that power conditioner everything else that was hooked up to that power conditioner worked, including the TAC. Nothing else had a problem. And I know that power conditioner is excellent, that Furman. I know this thing is an excellent product, and there's just no way this thing would let through an abnormal voltage. However, I really got to thinking about it, and there's one feature of this Furman that probably actually caused that protection to kick in. And this will be real handy to know for anyone that has that Furman, I don't even know the model number of it, my apologies, or something similar to it that has a similar feature, and I'm going to explain what that feature is that I believed actually caused this amp to go into protection mode. And there's nothing wrong with the amp. The amp was doing its thing. The microprocessor did a good job. Again, oh, I don't have the schematics down here anymore. No, I don't know what I did with them. Again, when you turn the power switch on, the first thing that happens is, before the relay kicks in, that sends power to the main transformer for everything. There's that little sub transformer, the one that I tested. That powers the microprocessor first. The microprocessor does all of its checks, and it's got 8 different protection modes. Maybe maybe 7 different protection modes. And the microprocessor takes in these 7 different inputs from different parts of the amp, and if something is wrong, if a certain voltage is wrong, it won't allow that relay to kick in that turns on the main transformer. So it was doing its thing. but I believe that it was caused by the Furman. And it wasn't an overvoltage that actually the microprocessor detected. It wasn't an overvoltage at all. The Furman protects against that. It was actually an undervoltage. And I'm theorizing here, I'm speculating, postulating. But I'm going to test the theory. I'm going to see if that's actually what happened. So, the feature of the Furman that I believe caused the issue is the fact that when the Furman loses power, and we lost power during this process several times, you know, it loses power, so of course it turns off. Whenever it turns on, it doesn't just immediately provide 120 volts to the equipment. It ramps the voltage up slowly. Let me see if it'll do it with the power switch. Okay, I just turned it off. Now watch the voltage readout. See that? It ramps it up slowly. And the reason I've never had an issue with that Furman before is because normally my amp is off. Okay, the switch is down, the amp is off, and I don't use the Furman to turn my equipment on and off. I leave that thing on and just use the power switches for the equipment. But so, you know, if there was ever power, and there have been power failures when I've been sleeping in the middle of the night when I'm not using the stereo, this switch is off. So nothing's running. There's no protection circuit running, nothing like that. I mean, nothing's happening. But during those storms, I had this amp on. And then the power went out. The power goes out, but the amp is on. So the Furman goes off, the amp goes off, right? Well, this switch is still on. So when we got power back, the Furman powers up, this switch is on, the Furman powers up slowly, and during the course of that 3 to 5 seconds when that Furman is slowly bringing the voltage up, this microprocessor is sensing the inputs it needs to be sensing, and it discovers the power supply is under voltage. Okay, it was the PS amp protection. Okay, back to that. Power supply amp protection. Cause abnormal voltage. Abnormal could be too low or too high. So I believe it sensed that Furman powering up slowly and sensed an abnormal voltage, kicked in the protection circuitry. It was doing its thing, you know, doing what it's supposed to do, and that's what caused it. Now, to test that theory, I think I'm going to bring that Furman in here to the test bench and actually simulate that failure or that protection circuitry kicking in and see if we can make it happen again. And then I'll walk you through the procedure that I underwent with the self-diagnostic to reset it. And in essence, there was nothing wrong with the amp. So when I went through the diagnostic at the end, I just did a reset back, and there's a way to do that with the knobs here. I did a factory reset and to the software or whatever it is. However the microprocessor stores its codes, but it went back to a factory reset, powered it up, everything powered up fresh, the amp never knew anything happened, and the protection circuitry, the code was gone. So the error code was gone, and I've since been running it on the test bench here without incident. No incident. So that's my theory. So if, and I never thought about this before, but if you have equipment this may be applicable to other equipment, other than this Yamaha that has intensive protection modes, microprocessor based, that, I think the moral of the story is to turn everything off, because, as soon as there's a power failure, turn everything off. And turn all the switches off of everything and let the power come back before you return them on. That would have prevented it, and that's why I never had this problem happen before. But if you have this particular amp, and probably the whole series of AS amps, perhaps, and you have a power conditioner such as the Furman that ramps up the voltage slowly upon turn on, you do not want to have this switch on. You want to make sure you have it off. And I'm really glad I went through this exercise here, because I would have had to, under warranty, ship this thing away. Who knows how long it would be gone for. I might have had to pay one-sided shipping, and they would have probably done, if they were qualified, they would have done the same thing I did a reset, it worked, send it back. And also, if this thing was out of warranty, I would have been charged up the wazoo for that simple little thing. Okay, so the first thing I want to do is bring that Furman in here and try to simulate the failure. Make it happen again. You might think I'm crazy for doing that, but I enjoy this stuff. I think it's fun, it's interesting, you learn something. I'm not worried about it. Since it's already happened, I mean, this happened during the power failure. I don't think anything, obviously this protection system works just fine. Nothing's going to happen, but I'd like to simulate the failure to prove the hypothesis, and then to walk through the steps that I took to reset the factory reset, and also the first step of self-diagnostic to get that diagnostic code to see exactly what the microprocessor was seeing, the reasons for the protection kick in. And there was one other thing I'd like to do. Is when I wrote down some notes here as I was going through these 10+ pages because it was so confusing. But when I started the self-diagnostic, I couldn't get into the diagnostic mode because, of course, the protection circuitry was kicked in. It wouldn't allow the amp to power up, and it needs to power up to go into this mode. So the first thing I had to do was to cancel the protection. Now that's a bit dangerous, because if there was a flaw in there that would cause something to fry, then canceling that protection could be a bit dangerous in that sense, but I wasn't worried about it because the amp is protected in other ways too, and I'll bring it up on the test bench. If I see, hear, smell anything, turn it off. But there's no other way to go into that mode, so I had to cancel the protection. Once I canceled the protection, the amp powered up, and then I entered the diagnostic mode, and then I was able to get the codes. So I thought that was really interesting. So let's go ahead and try to simulate a power failure with the Furman, with the amp plugged into the Furman, and see if the amp craps out again. Hopefully it does, and then we'll know for sure the reasons for the protection circuitry. Okay, so I've got the Furman right here, and I have the amplifier plugged into one of its switched inputs, and the Furman is off. So the first thing I'm going to do is the amplifier is off, and let me just turn the Furman on and get the power up to normal. See, there's that slow rise. Now, let's make sure the amplifier works. It should. There's the click of the relays. I heard the speaker relay click, and there's our tone. So it works. Now, to simulate what happened during the power failure, the amplifier was actually running, so the switch was on, and I never turned it off. So during the power failure, I'm going to unplug the Furman. Although I could just, because it's a switched outlet, I could just turn the Furman off, which is the same thing. I think I'll do that. Okay, Furman's off, amp is not getting power. But this time I'm leaving that switch on. And this probably cycled a few times during that storm the other night, so let's see if that's what triggered the protection. Okay, turn it. Okay, actually amp works, but I noticed that the Furman started out at a higher voltage. It didn't start out at such a low voltage. So this time I'm going to simulate a power failure by plugging in, unplugging the Furman altogether. And I've just done that. And then I'm going to wait. I'm going to wait a little bit, just a few seconds here, let everything clear out, and then plug the Furman back in, just like during the power failure. Okay, I'm about to plug it in. Hopefully I can catch that voltage. It starts out at a low voltage, but the amp kicked on. It's working. Okay, let's try that again. Simulate a power failure. This time I'm going to let... I notice that the Furman's not starting out at the lowest of voltages it did before. Pardon me. So I'm going to let it sit for a couple minutes. I'll hit pause here. Alright, let's try that again. Amp is on. Furman comes up to full voltage. And it's still working. So my hypothesis that I'm testing is not working. So that would mean turn the power off. I'm going to try it one more time, but that would mean that there was some other voltage. Now it could well be because after the power went out, I went to bed. I didn't stay up. But I probably forgot to turn that amp off. So whatever was cycling in the middle of the night, or whatever was happening with the power company. Again, the Furman won't allow spikes or surges in the voltage to pass through it. But perhaps during the course of the night there was a prolonged low voltage from the power company, and that's what did it. Because the protection circuitry for the power supply it's for an abnormal input voltage, and abnormal could mean low or high. Amps that are designed to operate at a certain voltage, you know, with all the circuitry inside of it, you know, if you have a low voltage input, then the power supplies cannot achieve the voltages they need for the circuits to operate normally. So hence the protection circuitry would kick in to prevent that from happening. So I'm guessing somewhere during the night there was a low voltage for a prolonged period of time because the amp was left on, as the power company was kicking, switching relays and kicking things back on. And I know during that storm there were trees down all over the place and who knows what, but try it one more time. So no problem. That doesn't seem to be the problem. So I'm going to speculate it was a low voltage from the power company and leave it at that. I wish I could walk you through what I did. But what I will do is well, I'll tell you what, I will do that. Not that you should be doing this if you don't know what you're doing, but I'll just very briefly show you how to enter the diagnostic mode. I'll show you what LED, which is actually that one that blinks with the codes on it, and then how to reset the factory defaults, and to leave the diagnostic mode. And I'll show you what I saw and what I did to reset the whole thing. Fair enough. I think that's about all I can do at this point because I can't simulate the failure, obviously. I was so counting on the fact that this Furman caused it with the low voltage thing, but gosh darn it. Alright, well, we know something happened, and whatever happened didn't affect my other equipment. It only affected this amp. So this amp, the protection circuitry in the AS series amps, is particularly sensitive to low voltage. Or something, but hey, it did what it's supposed to do. That's the important thing. Whatever was in there that needed to be protected got protected. And nothing fried, and everything works. So let me try this one more time. And the amp kicks on. Okay, so I can't simulate it. Alright. I'll go ahead and walk you through the diagnostic mode, show you what I saw, then we'll call it a day. But I'm just happy, you know, I really didn't have to take it apart and check the fuse, but I'm just happy it's working and everything is, I did some measurements on the outputs, everything's perfect. So there's no issues here, thank goodness. Okay, so here's what I did. First thing I wanted to do was enter into the self-diagnostic mode, but I couldn't do it because the protection circuitry wouldn't allow the amp to, wouldn't allow power to the main transformer and all the circuitry to come up, which is needed for the diagnostic mode. So I had to cancel the protection, send a signal to the microprocessor to defeat the protection and allow me to start the amp. And to do that, I've got the amp off and I have power. I don't have power to the amp right now, so I can simulate this without actually doing it. But to do that, and this is all per the service manual, the balance, the bass, and the treble had to be rotated fully clockwise. And then I had to hold the mute button down while at the same time turning the power switch on. So I'm holding the mute button down, turning it on, and I'm holding the mute button down for 3 seconds after I turn the power switch on. As soon as I did that, I heard the relay kick in, I saw the lights come on the front panel. And at that point I was a little nervous. I'm looking, listening, smelling, feeling, you know, making sure there's nothing in there frying. And there wasn't. It sounded good. No issues. And by the way, I did this without a load. I didn't have any speakers hooked up. I didn't want to do that. Okay, so once that happened, I was able to follow the path back to getting into the self-diagnostic mode. And for that, I'll actually go ahead and start the self-diagnostic mode. So, let me put this on a tripod here. I should turn the light on too. Alright. Zoom out. Okay. Alright. Go ahead and turn the power on to the Furman. Alright. Okay. So to enter into the diagnostic mode, I'm going to start with the power off, even though I have power, I have the power cord hooked up and power coming into the amp. And I'm going to rotate the, just like before, balance, treble, and bass fully clockwise. And just like before, I'm going to hold the mute button down and start the amp. Now, you can't see this. I need the lights dim for this, but I'll just explain it to you. You know you're in diagnostic mode when the lights for the LEDs for the meters come on, but it's half as dim. It's in a dim mode, and so what you see is they come on and then immediately they dim. And per the service manual, that's an indicator that you're in the diagnostic mode. Now, you can't see this probably, but the light above the standby on, that's the light that blinks with the various codes. And I have to stand behind the camera here. There are a sequence of codes, and they're numbered 1 through 8. The first one is just a solid light, and this light is solid right now. It's not blinking, and that means normal, no protection function. However, when I did this, when I was having an issue, that light right down there blinked. It sequenced 8 times with a pause, and it started over 8 times with a pause. And 8 times with a pause told me that it was the amp protection, power supply amp protection. And of course, that's when I, went right to the service manual to read about it. And that's when I realized abnormal voltage of amplifier power source. And that's when I speculated it was the Furman, but I guess it was something from the power company. Most likely sort of a brownout, because the Furman won't pass high voltages through. And it for that reason it kicked it off. Now, knowing that, I went ahead and speculated, well, okay, fine, that I no longer have that issue. I've got fine power from the power company now, so how do we reset this whole situation, start over? Well, that's going back to factory reset. So now, to exit diagnostic mode, all I would have to do would be to turn the power switch off. And there's 2 ways to get back to a factory reset. One, I can do it while I'm in diagnostic mode. The other, I don't have to be, and I'm going to choose the other. So, but while I was in the diagnostic mode, I did a factory reset, so when I turned it off, it came up fresh. I don't know, maybe I should do that. No, maybe I will do that. So, I'm still in the diagnostic mode, and you probably can't see this, but there's a light below the mute, right above the mute right here, and it's blinking. It blinks 1 time, and then it has a long pause. It blinks 1 time, it has a long pause. And those blinks are an indicator of which menu you're in the diagnostic mode. And right now I'm in menu number 1. Oh, I'm fumbling through my pages here to find the menus. Hold on just a second here. Okay. So here are the menus in the diagnostic mode. And I'm in menu number 1, which is the main version. And that has to do with the firmware and that sort of thing. And I don't care about that. I want to get down to menu number 4. It says backup initialize, and that resets the factory defaults and clears the error code, and you're back to normal. So I'm going to go to the service manual for menu number 4. Backup initialize right there, and I'll read it to you, and I'll go ahead and do a reset right now. So backup initialize. Well, the first thing it says you do is you set the CD, the input to CD. And I think because I'm now on main direct, I'm on line 2, line 1, CD. Alright. Now, after selecting this menu, push and hold down the audio mute for 5 seconds to execute the initializing. Actually, I didn't do something right. My apologies. See, I'm just doing this off the cuff. I mentioned earlier I'm on menu number 1. I have to get to menu number 4, so I've got to keep holding this down. I got to keep hitting this until I get 4 blinks. I hit it again, and now I have 1, 2, 3 blinks. So I'm in menu 3. I hit it again, and I should be in menu 4. 1, 2, 3, 4. Okay, now I'm in menu 4. Okay, there we go. Okay, now I'm on CD input. Sorry about that. I'm on CD input. Okay, so let's try that again. Now I'm on CD input. I hold the mute switch down for 5 seconds. It says the input selector indicator CD will light up and normal operation will be restored. So 5 seconds. Well, I didn't see anything light up, but maybe it's because the thing has already been restored. But I held it down for 5 seconds. Now it says the actual initialization will be executed when the power is turned on next. So now, as I mentioned before, to exit diagnostic mode and to reinitialize, all I do is turn the power off. I'm just going to go ahead and turn these back to flat. I don't think I have to, but... Okay, now let's turn it on, and everything lights up. The meters are now, you probably can't tell, but the meters are now glowing bright. That means I'm not in the diagnostic mode. And there's our test tone. Right channel, left channel. Bass and treble work. Input selector works. Okay, so it's been factory reset. So that's the process that I went through. Now there's also another way, if you don't even want to enter, and this might be important to some people, if you don't even want to enter the diagnostic mode, there's another way to reset the factory settings with respect to the clearing any codes or with respect to the firmware and that sort of thing. And that other way is we start with the power off, and I'll just go ahead and do this. I don't think it's going to hurt anything to reset it twice. So this way, again, we don't have to enter the diagnostic mode at all. We're just starting fresh. And I don't know why I'd ever want to do this without entering the diagnostic mode, but I'm just going to read what it says, okay, in the service manual. So resetting factory defaults. Okay, so we start with the power off. Turn the treble knob and the bass knob counterclockwise, fully. So treble counterclockwise, bass fully counterclockwise. And then while pressing the audio mute switch, set the standby on switch to on. Okay. I'm holding the mute switch down. I just turned the power on. It says then turn the standby switch off, and the data is initialized the next time the power is turned on. So that's another way to revert back to factory factory presets, but all those presets have to do with mostly to do with codes and protection codes and that sort of thing, because there's not, this isn't an this isn't a computer-based device where a user can go in and make all kinds of adjustments and settings. You know, it's not like a, you know, an iPhone or something. When you reset that to factory, everything is lost. You know, it's not like that. So I'm not sure exactly, other than clearing the protection circuitry codes in there, I'm not exactly sure what that's resetting. But I'll leave that for another day. But anyway, that worked, and the amp is functioning perfectly now, and I'm about to happily go put it back into the system. So that's that, and I still wish I could simulate the reason that protection circuitry kicked on. But my best guess, I know I said it before, I'm just thinking out loud, my best guess is a brownout during the electrical storm for a long enough period of time where the amp just said enough's enough. And really, the moral of the story for all this stuff, well, two things. Number one, get an excellent protection system, an excellent power filter, such as this Furman. There's many of them on the market. I mean, but something like this will definitely prevent surges and spikes. It has a soft turn on, as you saw there, which it turns out did not affect my amp, because I've tried it. It protects from extreme voltage, spike surges, that sort of thing. So that's number one. I think that goes without saying when you have circuitry, you know, you care about. What model number is this? I don't even see a model number. Oh, there it is, right at the bottom. See, I'm half blind. I gotta take my glasses on, put them off. Elite 15i power conditioner. So number one, get this. But number two, I remember one of my first electronics classes ever. We were in the lab, and the teacher was at the end of the, you know, after you set up your oscilloscope and you know, set up your little experiment and your voltmeters and that sort of thing, the instructor would say, oh, when you're all done, hit the lightning switches, or turn off the lightning switches. The lightning switches. And you know, he said that many times before I fully understood what he meant by that. What lightning switches? What are you talking about? Is there such a thing as a lightning switch? And what he was referring to is unplug the damn equipment. Unplug it. Now, I don't think that that's necessary with a good power conditioner, such as the Furman, or many, like I said, many others on the market that are good. So unplugging is not necessary. The Furman is a good enough lightning switch, but I think it's critical, having learned this lesson with these microprocessor-based protection systems, to keep that switch off, if you can, during severe thunderstorms. And again, I was playing the amp. I was sitting out back enjoying the wind and the rain and everything else, and the power was going off and coming on and going off, and I never went in and turned the damn switch off. I should have just turned the switch off right away and not even worried about it until the next day, until everything was restored. I think that's the moral of the story. And again, I think that's probably self-evident to a lot of people, but I just didn't think about it, and that's what caused it. And that's the lesson that I learned out of all this, other than the lesson of going through the self-diagnostic, which saved me a trip to a warranty service call, which is a real pain in the ass. So, and also I realized that I didn't really have to tear this thing down and check the fuse if I just would have read the damn service manual a little more closely ahead of time. But again, for some reason I thought I needed a special service tool or something for this diagnostic, but it didn't. It's all right on the front panel if you follow the directions. So live and learn. I think it was a worthwhile experience. I enjoy learning things and going through these processes, and I have fun doing it. And I was going to go ahead and do the whole thing real quick and get my amp back in the system, but I figured I haven't made a video in a while, so I'll go ahead and make a video of the process. And even though it's kind of a disjointed video and I go off on a wild goose chase with fuses and testing voltages when I didn't have to, but hey, it's a learning process, it's a journey. So I hope that someone found this interesting, and I hope to be back soon. I really, you know, I'd be curious to get, if anyone makes it, this will be a test to see if anyone makes it to the very end of this video. I often wonder how soon people bail out of my videos early when I start yakking. But there was this, I subscribe to the RAG stereophile. And I have a love-hate relationship with it because I think a lot of their reviews are just bullshit, and I almost enjoy reading the reviews just to for the enjoyment of being infuriated half the time with some of the crap, some of the garbage I see. I just sense a lot of bullshit in that magazine. It's just my personal thing. I just have a feeling. I don't know. I better not. I'm not going to speculate any further. But there's a lot of. I think there's a lot of bias there, and I think there's a lot of overhype of products that really aren't that good. And I gotta wonder why they choose some of the equipment they choose to review. But every now and then I find a worthwhile article in there, and it's worthwhile enough to keep subscribing. And certainly the editors and the reviewers and the authors, I mean, they're very educated people, and it's enjoyable to read. I mean, they're very well versed, and it's enjoyable to read. And I like reading the technical testing of equipment and that sort of thing. It's here I am talking myself back into liking the damn magazine. I subscribe to it, you know, but some of the subjective reviews I just have a problem with. But maybe one day, I'll tell you what, when Stereophile reviews the AS-1100 or one of the members of this family, and they actually give it a good review because it deserves to have a great review, then I'll come back into the fold. How's that? But anyway, what the hell was I talking about? Oh yeah, so they recently reviewed this amplifier kit, and I think it's called Akitica or Akitica. I don't remember the model number. It's an integrated amp, and it was an amp that's based around a fairly highly regarded older model integrated circuit chip, and which, you know, I'm not a fan of ICs, but some of them are, you know, some of them can be pretty good. They're interesting, and they gave it a pretty darn good review. And it's a pretty inexpensive amp kit, and you can buy it. You can purchase the thing for a couple of $100 extra. I don't know what, I forget the prices. 300 something and 500, 600 something assembled, and 300 something for the kit. And I was intrigued by it, and not so much the fact that I buy the review as to how good it sounded, but I haven't built a true kit since decades before Heathkit went out of business, and I don't know how long ago that was. I used to build kits when I was a kid, and it looked like a pretty good bargain for a kit, you know, just for the process of going through it and building it. And, you know, you just got to set aside what the end product is. It's just the journey of building it, and it looked really kind of fun. And I was thinking about buying that kit and building it and making a video of the build and then doing a review of it. Now, those guys gave it a pretty good review, which I don't give a whole lot of credence to, but I'd like to compare it to this amp. And maybe that'll be the day. If that thing actually compares well with the AS-1100, then maybe I'll be sold that integrated circuits can be the real deal. I don't know. basically an amp on a chip, but there's a lot of peripheral circuitry, and the power supply looks pretty good, and there's a lot of factors that go into a good amplifier. The power supply plays a huge role, but everything in the signal path does too, for that matter. But it looked pretty intriguing, and I think I'll do that next. If anybody wants to throw me a comment, if anyone has any experience with that Akitica integrated amplifier kit, let me know. I mean, I don't know anybody personally that's into this hobby. I don't have any friends, or I don't belong to any clubs or anything. I just do this alone on my downtime, so I rarely get to talk to anybody. I don't have any sources of information, and I hate going into those chat rooms with audio people. It just drives me up the wall. I can't do that. I probably should. I probably need to get over that bias, but I like talking to people face to face, one to one. But internet chat is just oftentimes big freaking pissing matches, and I'm not into that whatsoever. I'm not into insults and all the other little petty shit that goes on. Something about internet commenting and chatting just reduces adults to the mindset of 12-year-olds. I'm not kidding, man. It happens all over the place, and I'm not into it. But anyway, I'm gonna really thinking seriously about ordering that kit and building it and making a video of the whole process. And if it turns out to be good, maybe someone else would want to do it, or to buy the one that's already built. But it's certainly not what I consider to be hi-fi, but who the hell knows? I mean, maybe I should open my mind and really give it a shot. I think I will. So, unless I hear some horrendous comments from people about how bad that amp is, I think I'll try that next. And again, maybe it'll make for an interesting video for anyone who wants to see a build. I'm certainly not... I'll talk more about that later. I'm not the greatest kit builder. I'm not that good at soldering. I know how to do it. I've been doing it for a long time, but I have a shaky hand, and I have piss poor vision. I have 3 different glasses I need to go between when I'm, it's just, I'm not that good at it. I enjoy the process, but certainly I don't espouse to be someone that you should be looking at to learn from in terms of building kits. But maybe that's a good thing. Maybe that'll make for an interesting video. So, but anyway, thanks for watching this one. I'm sure this went on way too long as usual, but I haven't made a video in a while, and I hope that for those of you who made it to the very end, enjoyed it, and always appreciate a thumbs up or a positive comment. Thanks, and ciao.